Everyone to the happy hour with our NASA experts. We've got Ryan Joyce with us, a past RASC-AL competitor and now part of the Systems Analysis and Concepts Directorate at NASA's Langley Research Center. I'm Janice Miller. You met me a little bit earlier in the forum, and now it's the end of the forum, and it's a chance to celebrate your hard work this past year. We hope you've got a mocktail to showcase, and if you do, we want you to flip on your camera and show off your beverage. I've got my green one right here.
I've got a green one too.
Mine will be coming. We're just waiting for dry ice. So,
Ooh, that sounds pretty nice.
Mine is not mock.
That's okay too. It makes for a more interesting conversation, right? I wanted to offer a toast. So from my personal favorite space novel, Space, says the introduction to the guide, is big, really big. You just won't believe how vastly, hugely, mind-bogglingly big it is, and so on. Extra credit for anyone who could name that movie in the chat. It's pretty easy.
It's
and
a book.
a toast to all of us and to our subject matter experts who have joined us here today. To the guardians of the galaxy, these challenge competitors, our RASC-AL competitors, who have labored on a year on projects to send humans and technology to galaxies far, far away, where the space is the final frontier. To infinity and beyond, raise your glasses to the end of these projects and to the start of many contributions to pushing the NASA space exploration envelope. Cheers.
Cheers.
So I wanted to say thank you for everyone to joining this virtual event and participating in our virtual experience. We will be presenting some awards later this evening, as you know, and I hope you've had fun during the time together. And I wanted to turn it over to Ryan to kick off tonight's conversation with our NASA experts. He will introduce everyone. We ask you to please use the raise hand feature on this platform to get in the queue to ask your question. I will also be taking a look at the YouTube channel if we have overflow on there. And so you can also submit some questions in the chat. We ask you to go ahead and turn off your video if you're not a panelist and to mute your microphone. And I will turn it over to you, Ryan.
Hello, everyone. I'm Ryan. It's a pleasure to be here for yet another year of RASC-ALs, which is an awesome student competition, which Janice mentioned I competed in not so long ago. I think it's counting only about 5 years since was the year I competed, and am now on the other side. So I'd like to give a brief introduction to all of the panelists we have here today, beginning with Dr. Dale Arney, who is part of my branch at Langley Research Center. He's working on on-orbit space assembly, manufacturing, and all sorts of really cool initiatives associated with a lot of topics that are relevant, or a lot of capabilities that are relevant to the topics that are typical in RASC-AL themes for the large human space exploration spacecraft. Then we've got Dan Masnick, who has been working on all sorts of exploration, largely with humans, but also with robotic spacecraft as well, including small bodies, asteroids, and some of the bodies in the main belts. Then we've got Dr. Matt Simon, who is also in my branch, just like Dan. I forgot to mention that as well, who has been working on lunar habitation as well as some other in-space habitats throughout the years, and working on the Artemis program as well. And then we've got Dr. Doug Trent, who's been working on both Mars and lunar exploration plans these days. And now I'd actually like each one of them to give an introduction for themselves. So Dale, would you like to cover a little bit more about what you do in more detail?
Sure. So my name is Dale Arney. I am a systems architect at Langley, and so what that means is I think of kind of new concepts for spaceflight and how all the pieces fit together in order to achieve these ambitious missions. One of my kind of specialties is technology assessment. So looking at new technologies, what kinds of cool missions do those technologies enable, and vice versa. If we want to do a really cool mission, what kind of technologies do we need in order to make that a reality? And so I guess the reason, and so that got me into OSAM, which is on orbit servicing, assembly, and manufacturing, which is a set of capabilities that includes things like refueling and repair and replace and upgrade, but also like assembling really large telescopes and manufacturing 3D printing things on orbit. So that's kind of what I've been doing lately. I guess why I'm here is as the Venus expert. I was a co-lead for this study that we did several years ago called HAVOC, High Altitude Venus Operational Concept. And it's a look at kind of what it would be like if humans went to Venus. You know, what would we, you know, how would we do that mission? And so a lot of you probably know my friend Chris, who's on these RASC-AL things. He and I started this basically from a conversation that we had in the hallway. We said, you know, what if we went to Venus? Like, what would that look like? And we pitched this study where air actually floats in the atmosphere of Venus because it's very dense, and they wanted us to look into it more. The directorate did. So Chris and I went on this adventure together, and we realized that Venus is fairly poorly understood. There's my friend Chris. Venus is fairly poorly understood, and so we looked at like a campaign of missions going into the atmosphere using these airships, first robotic airships that would fly around and understand the atmosphere, then move to like short stay humans, which the video on YouTube shows the concept for that, and then moving on to like a sustained presence ISS at Venus, Cloud City type of thing. So that's you know, why I'm here and what we did, and I'm looking forward to all of your questions about Venus and OSAM and other topics that, you know, I have opinions on.
Thank you very much, Dale.
Yep.
Now, Dan, would you like to give yourself a little bit longer introduction as well?
Sure, I'll just say a few words. Similar to Dale, I'm a senior space systems engineer or space systems architect here at Langley. I've been here, this is 32 years now, this is my 25th year with NASA. And I've worked on a variety of mission designs, ranging, we started out, actually Pat and I started out on the Space Station Freedom Office. And it's evolved into what we are now, the Systems Analysis and Concepts Directorate, where we look at advanced systems concepts, ranging from human to robotic missions. I've worked on, most recently, before the current effort to go back to the moon, I was serving as the mission investigator on the asteroid redirect mission. The missions that we formally have looked at NASA have been to near-Earth asteroids, large, small, but more accessible. The main belt obviously is a different beast in terms of delta V and accessibility, but it offers, you know, that next step, or a parallel step to Mars. Our stated goal right now is Moon to Mars, but after Mars, before Jupiter, there's a vast reservoir of primordial objects out there that are interesting and represent resources that we can access. So that's my interest in furthering exploration of the solar system, because I'm a firm believer that we've got to, if we're going to go with any sort of conventional method until we get anti-gravity or antimatter, we're going to have to live off the land and have to be able to extract resources in order to settle the solar system. So each destination, including the main belt, offers that potential. Is that good enough?
Yeah, that should be great for now, Dan. And I'm sure we'll have some questions that focus on those topics very soon. So Matt, would you like to give us a little more in-depth background about yourself as well?
Yeah, sure. So my name is Matt Simon. I've been at NASA for about 10 years and working habitation stuff for about 15. I'm actually a former RASC-AL alum too from, about 14 years ago. Mostly what I do on the day-to-day is design habitat designs, interiors and sizing habitat systems for different mission designs. Really similar to what you guys, many of you experienced during this RASC-AL competition. So I do that for Moon, Mars, any other destinations that NASA decides they're going to go to any given year. Yeah, in addition to doing habitat design, I also have worked medical projects and radiation shielding projects and a few other areas related to habitation, in addition to doing more generic mission design type stuff like some of the folks here have done. So, yeah, it's good to talk to you. I'm looking forward to questions.
Thank you, Matt. And one quick plug before I ask for your background, Doug. Don't forget, people in the who are attending right now, feel free to start raising your hands, getting in queue with your questions for everybody here, because as soon as we get Doug's background, we're going to open it up to the whole group to start asking questions, and I'll call on folks who raise their hands. So Doug, would you like to give a more detailed background about yourself for everybody?
Yeah, sure, no problem. So my name's Doug Trent. I've been with NASA now getting close to 10 years, although I only recently finished school in 2017, finished my graduate degree at Georgia Tech. I'm with the Marshall Space Flight Center in Huntsville, Alabama, although like the rest of these guys, I am too also a space systems architect, space systems engineer. So kind of the similar gist of, what all the guys here have already said. My focuses over the last few years, though, have been heavily tailored towards lunar systems architecture, really supporting a lot of kind of conceptual design and trade space analysis for the human landing system during its formulation days and even up until now. And then also, obviously the reason I'm here is I also support the agency as the entry, descent, landing, and ascent lead for the agency's Mars architecture team. So what that means is basically I've got design authority, I guess you'd say, on some of the key elements for the human Mars architecture. So obviously the Mars ascent vehicle being the ascent component of that, but also entry, descent, landing systems for Mars, which is what you actually see right here is the Mars descent system. So happy to be here, and I'm looking forward to answering some of the questions that come up today.
Awesome. All right, so looking at the list of participants, seems we don't actually have any raised hands yet. So, it looks like Joseph raised his hand. Joe Cunningham?
Yeah, hi. I just have a question for Dan about asteroids. I've done a little bit of work on a couple of projects for asteroid mining and prospecting type of thing, and I was wondering about what NASA or industry, as far as you know, has planned as far as exploiting the resources of NEOs.
Yeah, so that's an interesting topic because up until 2016, there was quite a bit of interest, and the asteroid redirect mission was NASA's parlay into assisting that fledgling industry. But with the cancellation of the asteroid redirect mission, I think a good deal of the interest has waned a little bit. I know there are companies that are still advocating the use of resources from asteroids, but it's kind of been put on the back burner a little bit. I'm a firm believer in getting resources where it makes sense and using them where it makes sense. And on the lunar surface, it certainly makes sense to utilize lunar resources, but transporting those off the lunar surface and trying to use those in space is difficult until we have the infrastructure potentially to launch those resources in a more efficient manner off the surface. So asteroids give the benefit of being outside of gravity wells, and they offer some unique challenges, obviously, because they're a microgravity environment, and depending on the nature of the asteroid that you're going to, it may be a rubble pile that you have to work with in this environment. But I think there is still quite a bit of interest, but I think it's kind of been put a little bit on the back burner. Does that help answer your question, or?
Yeah, I much appreciate it. It's something I'm really interested in, so hoping it comes back to the front burner.
Yeah, likewise.
Yeah, I am also pretty interested in asteroids, and if it turns out we don't have a ton of other questions, I'll come back with a few. But in the near term, it looks like we've got a question for Dale. Josh Martin says, a bit off topic, but you mentioned working as part of the OSAM mission. I've worked with satellite servicing research for a few years, and I'm super interested in the upcoming OSAM-1 mission. I'm wondering what you foresee the next stage of the OSAM program and possible future objectives for OSAM and in-space assembly in general after the completion of OSAM-1.
How much time do we have here? So for those who aren't familiar, current NASA funding is for OSAM-1 and OSAM-2. They're two missions that are focused on servicing, assembly, and manufacturing. OSAM-1 has a component of all three: servicing, where they're going up to a satellite and refueling it; assembly, they're actually building an RF antenna from little segments; and then manufacturing, they're 3D printing a large beam. And then OSAM-2 is another mission where they're 3D printing the structure for solar arrays. So to answer your question about what's next, there's kind of a lot of different ways in which we can move forward, and really industry and the commercial applications are leading the way. So a lot of emphasis around servicing, so refueling or providing propulsion for vehicles that are up there. That's current state of the art. So the MEV at Northrop Grumman is latching on to a satellite that's in geo and providing propulsion to extend its life and to get back some of the or to increase the revenue that satellite can generate. Other applications that maybe the government would be interested in, things like, we call it persistent platform, but think of like a spacecraft that can host payloads. It has some robotic capabilities, and it's kind of like you're renting space on a spacecraft, and you pay for your power and the communications that you use while you're up there. So if you have an idea for a new instrument or new technology, you can put it on orbit and kind of leverage the infrastructure that's there. Another thing is building really big stuff, like things that you can't realistically deploy. James Webb is probably at the limit of what we could realistically deploy. But if we want to search for exoplanets or something like that, you need really big, like 20-meter plus telescope apertures, and it's reasonable to believe that you would assemble those in orbit from parts. And then to kind of tag on to what Dan was saying, my vision of the future is that you wouldn't necessarily have to ship up a bunch of raw materials into space in order to manufacture things there. You could actually leverage the resources that are kind of in those are outside of those gravity wells that are already in space, and use those materials to create propellant, to refuel things, to mine like the metals and stuff like that to make your spacecraft parts. And so that's kind of the 100-year vision.
Yeah, thanks for that, Dale. And I'm
Yep.
sure I'll have a follow-on question for you in
right.
in a little bit.
I mean, there's a lot more to it. I was trying to be terse so we can get to other questions, but
Yeah, understood. but definitely an interesting area, and a lot of interest in human exploration too, with going to Mars and the types of large spacecraft that will be necessary to send humans there. So I'd like to transition to a question for Doug that I have, since it looks like we've still got only a few questions in the chat. So Doug, if I recall correctly, you've been working on NASA's minimum MAV concept study. And I'm curious because, you know, it so closely aligns with one of the themes of RASC-AL this year. What are some of your favorite ideas for reducing MAV mass? And then, you know, maybe those could be a little bit out there. And then, but beyond that, what do you think some of the most promising ideas are?
Okay, so it's a good question. Obviously, reducing mass of the MAV is super important. The MAV is a little bit unique in the architecture because it's got to climb out of the biggest gravity well that we go into for the mission. So in terms of kilograms of propellant per kilogram of other stuff that's on my vehicle, it tends to be the most sensitive. It's a lot more like a launch vehicle than it is any of the other elements. And so obviously if I can shave 1 kilogram out of the MAV, right now, the current concept, it'll save me anywhere between 4, 6, maybe 7 kilograms of propellant. So that's really important just because the other part of my job is the descent system. And so the lighter the MAV gets, the easier it is for my descent systems to deliver that payload to the Martian surface. So obviously that's super advantageous. Now, in terms of concepts or things that we could do or that I really like in terms of design that can really help reduce it, there's lots of different ways. For a minimal MAV though, obviously one of the biggest things is the number of crew that I'm taking to the surface is going to really be one of the biggest drivers in terms of how big that MAV has to be. So obviously if I only got to return 2 crew from the surface versus 4, that's going to be a lot less volume for crew to live in during the ascent period. It's going to be less environmental control systems, less power, just less consumables. Everything gets smaller with the number of crew. Our squishy payloads are usually pretty dependent on a lot of things, and so the more we take, the more it takes to get them back. Now, obviously, that's very much in contrast in terms of going to Mars and the things we want to do, the science that you want to do. The more crew you have, typically, the more capable you'll be on the surface, and so obviously, there's a lot of trades there with capability and also, you know, minimizing mass. Now, obviously, there's lots of other design things we can do too in the architecture to reduce the mass of the MAV. But in most things related to space, you don't get anything for free. And so, for instance, one example might be currently our minimal MAV concept is doing an ascent from the surface of Mars all the way up to the aggregation point that our transit hab sits in. So right now that architecture has the transit hab in a very highly elliptical 5-sol orbit. Now what that means for the MAV though is that it's got to do a pretty substantial amount of work to get up from the surface all the way up to that transit hab. And so obviously the more amount of delta V it's got to do, the more propellant, the larger the vehicle. And so obviously adjusting that aggregation orbit to maybe be something lower that now the MAV doesn't have to do as much work to get up to will significantly reduce its mass. But obviously, like I said, nothing comes free. So that's going to take a lot of work in terms of integrating with the transit hab, because now if my MAV is only going up to 1 sol, my transit hab or whatever pushes my transit hab to get the crew to and from Earth and Mars has to come down to that specific orbit. And so now that's going to incur a mass penalty somewhere else in my architecture. So as much as I like to reduce the mass of the MAV as much as I humanly can, I got to be cautious of how that might impact other components of the architecture as well, to, you know, make sure that we do have as much an optimal architecture, not just element design as possible. Just because, I mean, the MAV is one of the primary elements in the architecture, but again, it's not the only one. And so making sure that we make smart trades between all the various components of the architecture is also something very important to me.
Yeah, and that resonates with me, and I think it resonates with probably most everybody who competed in this particular competition, because it's an integrated systems problem, right? I mean, you're not talking about optimizing one system, you're talking about balancing all the different pieces of a different architecture and all the systems that it takes to actually keep humans alive on the way to Mars and then get them back home safely. So really appreciate that, Doug. Looks like we've got one more question in the chat for Dale, but I'm going to interject with a question for Matt here real quick, just so that we get everybody on the panel up and talking quickly. So Matt, as a habitat designer, I'd like to know, what are some of the biggest differences from a habitat designer's perspective between designing for a planetary surface as compared to microgravity or deep space?
Okay, I mean, there's a bunch. The most obvious one, of course, is like you have gravity on the planetary surface, you don't have gravity in space, right? Typically, though, we tend to design systems that are capable of operating in both. So, for example, the life support systems that are being designed for, if you were trying to use a closed-loop life support system on the moon and in space, you would try to design them to be comparable. You get more test time out of them, and it's already a pretty substantial development. They have to be tested in 1G anyway, so there's a lot of analogous piece parts. There are things you definitely could simplify, for example, on a life support system if you were going to design it for a planetary surface, like, in space you use like a centrifuge or some other a positive expulsion bladder or some other mean to transfer fluids in space, because you don't have the gravity that pulls everything down to the bottom where you get good suction from the pump. So what you could do on the surface is just rely on gravity to pull the stuff down to the bottom and just siphon and suck off the bottom of a tank, right? So there are ways you could design things differently but typically for like some subsystems, we try to design them similar. There are other ones where we can't do that, right? EVA suits are vastly different between the two because of the mobility and the need to carry all that stuff on a planetary surface. There tends to be a little bit of a different usage of volume, right, because of the difference in gravity. So, for example, you can float in any orientation and access any nook and cranny of your in-space habitat, but once you get on the surface, you're kind of limited to standing height. Yeah, I mean, there are tons of different aspects of design that are slightly different. But you'd be surprised, since we design to floors anyway, for the most part, between surface and in-space habitats, the design can be roughly comparable. You still want the same things. You want separation of functions that don't make sense to be next to each other. You want a good layout that helps you to be able to access all the different subsystems. You still have to think about ergonomics in both areas. So yeah, there are a lot of differences. I think that's probably a pretty good answer. Did I tease to the part of the question you were hoping I would answer, Ryan?
Yeah, I think so. That one's mostly just to get people thinking, get some ideas spurred in the participants and the students, to see if it spurs some other ideas and questions that they might want to ask you as well.
Yeah, golf would definitely be harder in space. So,
although we have played golf on the moon.
That's right.
So I look forward to them playing golf on Mars. It looks like we do have another funny question from the chat. So Obadiah asks, for developing the ISS or Cloud City Station for Venus, would the biggest impedance to crew returning be either the ability to produce fuel or the ability to build the floating platform from a technical perspective?
So when we did Havoc, we did not assume that it would be very easy to produce the fuel. There is some oxygen in the CO2, but there's not a lot of hydrogen in the atmosphere to make like methane or anything like that, like you would have on Mars or something. So we took the fully fueled ascent vehicle with us, and then the actual buoyancy of the airship, we used helium for ours. The atmosphere is so dense that the buoyancy is pretty good. So I actually don't think either of those are the hardest challenge. I think the hardest challenge is what we called EDI, or entry, descent, and inflation. You know, we've never gone from, you know, entering into an atmosphere to inflating this giant airship while we're entering, and then you know, floating off all epic like. You know, we've always landed on a surface, and we've had some like retro propulsion or something like that to stop us, or airbags to bounce around. So, you know, that was probably the biggest kind of technical hurdle that we would have to tackle when doing this, and that was one of the reasons why we came up with this idea for like a campaign of a bunch of robotic missions, kind of similar to what we're doing on now, in preparation to, you know, understand the environment and all that stuff to prepare for humans going. You know, but at Venus, it would also serve to kind of help us figure out the technology of actually entering into this atmosphere and inflating an airship while we're going down, you know, maybe under a parachute, and then getting to a state where you can actually start flying. So that's kind of the rationale that we had going through.
So it looks like we then have a more general question, which I think I'll open up to every panelist to respond to. And that would be, what industries can we see moving into space in the future? So I'm going to slightly modify it and say, you know, if you look long-term enough, I see every industry that's currently on Earth basically moving into space at some point or another. However, if we're talking maybe in the next 20 to 50 years, what industries do we think will be the first to jump off of Earth and into space? Oh, come on.
I can lead off unless Dan wants to, but
I thought Dan was reaching for his mic. So
Yeah, I mean, go ahead, Doug.
I mean, so me, I was gonna say, kind of actually riding Dan's coattail earlier on the fact that, you know, until we get some kind of advanced propulsion system, you know, something like an Epstein drive or whatever from Expanse, being able to live off the land or live off the resources that are out there is going to be really key. And obviously the first thing to being able to live off those resources is going to be able to mine those resources. And so I think being able to, you know, scale up or even initially provide any kind of, you know, resource mining operations, whether it's terrestrial on the surface of the moon or the surface of Mars or on asteroids, I think is going to be a key part to being able to gather those raw resources and then obviously be able to refine them. So mining, refining, and then obviously to do those typically on a scale that's going to encourage a larger space economy is going to require pretty substantial power demands. And so following or coming along with, you're going to need at least some kind of probably significant power generation system or power generation scheme to go along with wherever you want those mining and refining processes. So I think those are, in terms of the 20 to 50 year time frame, if you want to really expand out in the solar system, those are kind of the three that I think you're really going to need, is basically mining, refining, and power.
Yeah, and I'll just add to that. You know, Doug kind of hinted at it. Are you guys picking up some noise? Okay, I'm getting
clear through.
Okay, I'm getting some pop-up saying there's noise on my microphone. I guess it's hearing me talk. You know what? The thing that Doug talked about, some of these building blocks, which absolutely, you know, it's necessary. But I kind of really think that tourism is going to be a major driver in terms of the industries. We have an enormous amount of disposable cash in society, and I think that will really, and we're seeing it already in terms of suborbital flights, that people have this desire to want to move out, and I think those types of industries where it's not a necessity but it's a desire will help these other industries move forward. And the key to all this, in my opinion, like Doug said, until we get some advanced propulsion, is getting the cost down, because the cost drives everything. So as the cost for going from Earth to orbit get reduced, then that's going to enable these industries to really become financially to make financial sense for these industries to expand into space. The launch costs right now are still an impediment, and having reusable vehicles like SpaceX is proposing, or maybe some advanced technology that will come up, maybe not as far as an Epstein drive or antimatter, could help that if we can find an economical way of doing it. I'm fond of saying if we flew in airplanes across country and just trashed the airplane when we got to the destination airport, we would not be flying even pre-COVID days at the rate we've been traveling. So we've got to conquer those issues, and I think once you do that, it opens up a lot of industries that it starts to make economical sense. And another analogy is you look at the interstate highway system that was established. That was a government infrastructure to help spur, originally to move transport military vehicles efficiently across the country. But look at the economic growth that for better or for worse, the interstate highways have generated in terms of, you just look at all the businesses that are associated with that. So again, getting that infrastructure and getting those costs down will help a variety of industries.
I'll weigh in too, Ryan. I think space tourism is actually already starting to begin up. We're hearing about like being able to buy seats to the station, and suborbital flights is definitely already kind of there. It wouldn't be a big gap to potentially be able to do more like longer term orbital stays. Maybe not like permanent stations, but that may be the way that things are going. I know that we've gotten to leverage ISS for a long time to do all kinds of research and stuff too. So it would not surprise me if there were other areas that as ISS starts to age, there may be other areas where they're trying to build up some orbital capability from a commercial perspective to serve as a laboratory, to serve as a tourist destination. It seems to be a pretty lucrative business that people are starting to get into.
Yeah, I'd add, it seems like there's probably a lot of opportunities for research and development in space for materials science and all that, all the maybe even medicine and that kind of area of industry that isn't necessarily considered one of those ones that might be the jumping off points, but certainly could have some interesting discoveries in space if there's enough lab space for them to be able to conduct some experiments. And I know I'm personally looking forward to the day that I can spend a week of vacation on board a LEO space station and get to experience that as a normal person, not a rich billionaire. So
it needs to be longer than 10 days though, because you're going to be sick for like the first 2 or 3. So
you take enough Dramamine and you'll be fine. I'm kidding. But it looks like we've got another question for Dale about Venus. Joshua Martin asks, with the announcement of the new Discovery missions, what data from those would be most useful in planning Venusian atmospheric and surface robotic missions?
So from the Havoc standpoint, we were in the atmosphere. So any information that you could get about the atmosphere would help you better understand kind of what environment you're going to be in, what the kind of like the winds and the travel like around the planet that you would take. A lot of that we have like a handful of data points at specific locations, and so there's not a lot of understanding around kind of the bulk flow of the atmosphere around the planet. Those winds are pretty strong, and they do some crazy things. If I remember correctly, the 3 kind of big areas that the Venus science community wanted to understand was, what happens in the atmosphere, what happens under the surface, and then what happens kind of at the interface between the surface and the atmosphere, volcanic activity, that type of stuff. And And the way I understand those new missions, which I haven't been a part of or anything, they're trying to look at all three of those aspects. And so, you know, from my standpoint, getting longevity in the atmosphere at the appropriate altitude that you would send, you know, a human mission to, or even like a long duration robotic mission, like that information is crucial, because that really drives, you know, how big your airship is, how fast it has to travel through the atmosphere to counteract the northward drift and that type of thing. So really a non-answer, like you know, in all of the above, but you know, Venus is so poorly understood that, you know, any like quality information that we can get is going to be super helpful. I mean, we're still learning stuff about Mars, and we've been there for decades now.
Thanks for that, Dale. It looks like Amanda, you've got your hand up. Feel free to unmute and ask your question.
Hey, yeah, I do. Hey, how's it going? So I think some students may not understand the perspective of what you do day to day. So I have a kind of a broad, open-ended question. So what percentage of your time do you do with what things? Is it always proposal to proposal? Is it understanding what the scientific capability is within NASA and the industry? Do you look at cross industries? Are you always, you know, is it more independent studies that you're then bringing to NASA? And then my follow-up to that, is there ever a lack in ideas? Because I think probably what the students saw through doing RASC-AL, there's a lot of good ideas, but sometimes you're waiting for the rest of science to catch up.
So I can go first, I guess. So post-COVID, I probably spent a third of my time as a first grade teacher, and then the other 2/3 as a NASA engineer. But so from the OSAM National Initiative that I'm a part of, we're looking across the government. So we're looking at civil, national security, and even commercial space, and how they would kind of use these capabilities, use the infrastructure in space. So you know, I spend a lot of time talking to folks from other government agencies who also work in space, and trying to get that perspective. You know, we all five of us here, we have these kind of grandiose visions of the future, and some of the national security folks don't think like that. You know, they think much more tactical. And so, you know, bringing those together, what you find is that they do have a lot of interest in these capabilities. They just have a much more kind of near-term focus on how it's used. And so, you know, we're all kind of systems analysts, system architect types. So we do a lot of brainstorming of new ideas and really figuring out what's feasible, what's realistic. And in those cases where we don't necessarily have the technology now or the capability now, we get to the point where we can understand what the steps we need to take to get from here to there. So, you know, like our technology planning part of the job kind of helps us bridge that gap. Hopefully that answered the question.
Doug, would you want to take a shot at answering that as well? Oops,
Yeah, I
sorry,
can.
Matt.
I mean, it's definitely a lot of what just, you know, Dale had said, except for the kids part. I don't have that. So mine's 100% NASA time. But I mean, in terms of, you know, doing a lot of independent thinking and studying, yeah, we have a lot of that because, again, like you said, system architects, just a lot of conceptual ideas, and then obviously doing, you know, analyses to see what's feasible from a physical standpoint, but also maybe from other perspective as well, maybe cost or risk, or, you know, political even sometimes. So we do a lot of that kind of stuff. I know from my perspective and from where I sit, I do a lot of kind of independent study in those areas, supporting some of the the NASA programs, things like the Human Landing System program. I spent a good bit of time doing studies to provide information to the leadership in that program to make decisions that they do. Before we were in the situation that we are in right now with the program, I did interface with, commercial partners that we have in that program with their lander concepts to help them better understand, potential sensitivities to their architectures and things like that. But there is also, helping to write proposals for various entities, whether they're inside of NASA or outside, for various things. So like we'll do conceptual studies to help those entities understand their designs better so that they can write a more thorough or robust proposal for a specific thing to try and obviously win that proposal. So I do a little bit of that. Yeah, that's kind of my day to day right now.
Matt, did you have one piece you wanted to add as well?
Yeah, so I was thinking it through. I think everybody has slightly, across NASA has slightly different splits of their time depending on the nature of their work, right? So a detailed subject matter expert or designer is going to have a different set of splits between that and somebody who's more of an integrator and systems analysis type person, who may be a little different from somebody who's working a program, right? From my perspective, I work kind of to do design lunar architectures and habitats, kind of like both two parts of my time. So 50% of my time, is sort of meetings to stay coordinated with everybody. We have so many different disciplines that we have to get input from all the time, and are trying to merge those all into a strategy that we can go and present to Congress, present to our leaders, try to identify major breaks in our architecture. 15% of my time is spent on brainstorming, 20% working products independently, and then 50% is just like staying organized, right? Emails, reading up on things that people have sent you so you can be informed for the next conversation. So my role tends to be much more of an integrator, talking to people role, which is what I like about it. But that's definitely not the case for everybody, right? If you want to be an analyst and you want to be heads down on a problem for the majority of your time, there are definitely roles for that too, right? And that's kind of how we all start as well. In terms of lack ideas, Amanda, I don't think we ever run out of ideas. We always have way more things we want to look at than we have time or money to look at. We always have way more things we want to look at than Congress is willing to fund us for. So.
Well, the first part of that's great to hear.
All right, so looks like we got a couple hands raised. Dave, looks like you're at the top of the list. Would you like to go ahead and unmute and ask your question?
Yeah, as someone from the Apollo era, well, I'm not totally, but close. I was alive then. I have to say that the Mars ascent vehicle and the architecture that Pat laid out on the first day has always freaked me out, because it was a tenet of Apollo that you must always have abort to orbit all the way through entry, descent, and land. Well, no entry, but descent and landing. And it seems to me that the architecture that's laid out is, from the time you do the deorbit burn, you have to successfully come through the atmosphere, land, egress, translate across the surface, find the other ascent vehicle, ingress the ascent vehicle. The ascent vehicle has to work. And if any of those steps fail, you die. So how do you correlate that architecture with the desire to keep the LOC percentage as low as possible?
That's a Doug Trent question. Go ahead, Doug.
Oh man, okay. I was hoping Dan was going to take it. So yeah, going to Mars is certainly going to be a dangerous activity. There's no getting around that, really. Like you'd mentioned, our current architecture, we have the crew landing on a separate lander from the vehicle that ascends back up into orbit. So you're correct in saying that there would be no way to basically have always ascending back to orbit as an abort scenario. So during that descent, if something goes wrong, yeah, the crew could be lost at that point. In terms of trading that, the Mars architecture obviously is very, very large, very, very complex. And so there's lots of different knobs in the design that we can do to try and, adjust things, maintain higher levels of loss of crew. And again, like I said earlier, there's no free lunch. So obviously doing something like trying to accommodate something like landing the crew in the ascent module so that they can ascend and abort at any time during descent, that's certainly going to have penalties with it in terms of now the ascent module is going to have to provide a survivable atmosphere or survivable environment for the crew for a longer duration. Crew duration along with number of crew is obviously one of the primary sizing aspects of the MAV. And so now you potentially could have a larger MAV. It's going to have larger landers, larger transportation stages to get everything out there. And so obviously that's one thing we can have. But in terms of, a lot of people like to look at maybe one aspect. So yes, in that case, the descent component of the mission is certainly more risky than what we might have had in the Apollo days. But at the same time, you've got to kind of look at the mission as a whole as well, from basically astronauts leaving Earth to returning back to Earth. There's a lot of different components that go into the crew getting back to there. Descent is obviously one of the critical ones, but again, like you'd mentioned, ascent is very important too, making sure the ascent module is prepared and ready to go so that, we are as certain as possible as we can be from Earth, on the ground at Earth, for that MAV being prepared. So for instance, in our current architecture, the MAV lands partially defueled and we have to refuel it from a previous lander before it can ascend. So we want to make sure all of those kind of operations of making sure the MAV is refueled, doing basic checkouts of systems remotely to make sure, like I said, we're as certain as we can be before we send the crew down that MAV is going to perform its function as intended. So, obviously that helps buy down on some of the risk, and those kinds of focuses on a lot of the other architecture elements too. Obviously can be focused on for in-space transportation elements and things like that. So I don't know if that answers your question. If you have maybe a little bit more detail you want on it, feel free to ask.
Well, I guess it kind of comes down to, in Apollo, they told the crew that their estimate was that the chance of loss of crew was 10%. What are you going to tell the crew for Mars, what their LOC is?
Right.
10%. So, 10%.
So it's an architecture question, really. The architecture was set, and so these are the kinds of constraints that you have to live within. There are other architectures out there, and Pat put Hercules in the chat there, and that was part of a study we called ISRU to the Wall, where we have a I don't want to say it's starship looking, but it's a cylindrical body that lands vertically, and I think we came up with that first, or we released it first. But anyways, it has abort options all the way down, but it relies on refilling once it gets down to the surface. So there are lots of different architectures that you could go down to give you, maybe you have abort options during ascent, but then you got to give up something else. Like we've been saying, there's no free lunch. It's just an architecture decision that was made, maybe long ago.
Yeah, I'll just add, the reduction in risk is a function of the infrastructure that you have available and how much faith and not just faith, but how proven the technologies are that you're utilizing, the capabilities. For example, in situ resource utilization, we haven't proven that one iota yet. And to do it from Mars, particularly for the first time, is very risky. But if you've practiced similar types of ISRU utilization for lunar missions, for example, not only do you build confidence in that whole architecture and that scheme, but also in the technologies and the capabilities that are needed. For example, when settlers started crossing the United States, yes, it was pretty dangerous. The chances that you're going to survive getting even to your destination without even trying to come home was pretty low. But look at it today. We have the infrastructure that makes people, hop in a car and get on a road trip and go cross country because they know there's service stations and there's repair places, and space is different, but it's also in some ways the same. If we populate and expand out that infrastructure, that's ultimately how you make things safer, and you have multiple abort scenarios. You don't have just one place you have to get back to. So I don't know if that diverts from the question or adds to the answer, but that's kind of my take on it.
It's fine, and I don't want to hog the discussion. I think it's an interesting trade.
Yep.
Dallas, would you like to try and fit one, maybe two more questions in?
Sure, Ryan, thank you. So my concern is that everything we looked at this week in RASC-AL, I mean the students, going to Venus, going to Mars, or coming back from Mars, what will it take for humanity to attack all of these missions in parallel rather than the US approach of starting a program, ending a program, to start another program, and do them in series? And a parallel question would be, is your team starting to look at what can be done with 100 tons at a time to the moon or to Mars or to orbit?
So I can touch on that first question, and in my mind, it's infrastructure. Dan talked about the interstate system earlier. There's lots of other examples terrestrially of setting up the infrastructure, and then you're not going to a single destination and coming back. You're not doing these little one-off sorties. You've built up the capability to go wherever you want to, and if there's a huge market for, if there's a gold rush in California, then you have the ability to kind of mobilize and go do that. And so, I think taking that into space will let us kind of break this construct that we have of, we want to go do this mission. Here are the systems that uniquely do that mission, and then once we do it, we kind of start over and shift gears. I'll let someone else answer the second question.
Yeah, what about that second question?
I nominate Ryan to answer it.
Nobody's thinking about what to do with 100 tons at a time, huh?
I think it would be ill-advised not to be looking at that. We'll say that.
I mean, I have thoughts about that too, but I was going to let someone else answer.
Well, I mean, 100 tons at a time is pardon the pun, it's huge. I mean, when you can put that amount of tonnage up in one shot, whether it's a single piece or whether it's a group of pieces, yeah, you can start to build things that are on a much grander scale. Still not Death Star, level in space stations, but you certainly, and you can talk about putting up, inexpensively the propellant if you need it, or the ability to create that propellant from in situ materials. A lot of people say that ISRU will be destroyed by low cost launch because we'll just bring everything from Earth. But the two really kind of bootstrap each other until you get to this point where it would be just really, really, really inexpensive. And then of course we'd exhaust all the resources on Earth trying to expand out. So you'd have to reach out to those extraterrestrial resources at some point. But they really work hand in hand because it's less expensive to put the ISRU equipment up, and therefore it becomes more attractive to use the resources. So that 100 tons on each flight is a huge step forward.
And Dan, I would say that no matter what the cost of getting off Earth is, using resources at their from the location at the location is always going to be cheaper than shipping it in.
Yeah, unless the equipment that produces them is so massive or so inefficient.
Right. Yeah, there'll be a lower point where you can't. Thank you.
And I want to add to that because, we spend a lot of time, energy, money trying to make these spacecraft smaller, more efficient, more reliable, all that type of thing. If we have the mass to spare, we can do things quick and dirty, and maybe take two of them if we're not sure if one's going to last.
Yeah, you don't have to
And
spend $1 million to save a kilogram.
exactly.
You can save $1 million by adding a kilogram.
Yep.
Yeah, and it would be very ill-advised not to be thinking about what you might be able to do, especially in a branch or in branches that really are looking at the integrated system problem. And if you're not looking forward at what those near-term technologies might be, you'd be doing the U.S. government a disservice if you didn't have the ideas of what you might be able to do when you saw that.
Yep.
So I want to thank everybody who participated today and everybody for their great questions. It was a really nice conversation, and I wish we could have talked for another hour. I get the sense that we had plenty more conversations left to be had. But now I'd like to ask everybody to take a 5-minute break, maybe stretch your legs or get another drink, because we've got the awards ceremony here in just a few. So thank you very much for your participation, everybody, and really appreciate the panelists' time. See you in a
Thanks,
bit.
Ryan. Thanks, everybody.
Hi, everybody, and give us just a 2-minute potty break or a bio break. You guys can go refresh your drinks or just take a step around. I know it's been a long day of sitting, especially for our judges. So we will go ahead and get started at 6:35. Until then, we're just going to be off the air for just a minute. So, for the past year, but especially this week, we have been absolutely blown away by the awesome innovation, creativity, flexibility, and determination that you all have shown in your research and development and in the final presentation of your RASC-AL concepts. And for that, we just really want to applaud you and thank you so much for giving us the opportunity to watch you guys present your concepts this week. However, before we get started with our awards ceremony, we have just a couple of housekeeping things to share with you. This session is not being live streamed except to our YouTube account, but we will be recording the presentation of our top awards to be posted later to the Vimeo live stream. We'll also have each presentation and their Q&A session broken out there for you to enjoy later this week or sometime next week. So feel free to direct your friends and family and faculty there to view that at a later time. Next week, we'll be sending out the participation certificates via email and USPS for those of you who requested them, so keep an eye out for those. Our top winning teams will also receive a commemorative plaque with their certificate mailed to each faculty advisor. So we'll be reaching out via email tomorrow and next week to request appropriate mailing addresses for these plaques. Additionally, our first and second place overall winners have been reserved a presentation time slot at the 2021 AIAA Ascend Conference planned for this upcoming November, and will also receive a small award stipend to present. We'll reach out to our top 2 winning teams soon with more information about this. And finally, I just want to thank you all for sharing out the RASC-AL live stream. Over the past 3 days, it has received over 2,600 views, so including your friends, family, and faculty, as well as the guests that we've invited from NASA and industry. This incredible number of viewers is just an impressive testament to the innovation and creativity presented in your RASC-AL presentations. So now I'd like to officially begin our 2021 RASC-AL Awards ceremony by introducing Shelley Spears, NIA's Director of Education and Outreach, and the RASC-AL Program Director. Shelley, you take it away.
Thank you, Tori. I appreciate that. On behalf of NASA and the National Institute of Aerospace, a big shout out to all the teams and the faculty advisors. It's been a long year. Just appreciate all of the passion and dedication you've put in to this year's competition. I'd also like to thank all of our NASA mentors, the senior leaders and the champions at NASA Langley Research Center, specifically Mel Farabee, who was the director for the Systems Analysis Concept Directorate before he retired, and then now Laura Brewer, also Pat Troutman and Chris Jones. That SACD group, they're just amazing. You've heard several of them already that have former RASC-AL participants that have joined the ranks of the very esteemed SACD team there at NASA Langley Research Center. And also want to thank Doug Craig, who heads up the Advanced Exploration Systems group up at headquarters. Just appreciate all of his funding, and he provides a lot of air cover for all of us to be able to do this amazing competition year after year. And it's really those folks, their passion, that dedication that have really made RASC-AL perhaps the most highly revered and relevant university challenge for human space exploration in the nation. Also really want to thank the program team, an amazing group. So that's Stacy, Tori, and Janice for an almost flawless execution of 1,000,001 different pieces that go into executing this annual challenge with so many different stakeholders. Thank you all for your professionalism, your creativity, and the positivity that each one of you bring to the job every single day. I also want to thank our NIA's fantastic media and communications team. They really have been supporting us in this virtual environment. Specifically, Dave Shelton, thank you for being the WebEx primary lead. I also like to thank Robin Ford and Allie George as the backup, just in case we have redundancy. We do work in the NASA style of a lot of redundancy, so they were there always in the background in case something happened with Dave. Also want to thank Caleb Stern and Jim Lucas, who did all the live streaming for us. And last but not least, I'd like to thank our esteemed steering committee and our judging panel, Heather Rarick, Dallas Beanhoff, John Bradford, Ken Bokum, AC Chenaria, Melvin Farabee, Amanda Ireland, and Chris Jones. Thank you for sharing all of the time and passion that you bring for the good of the nation, for NASA, and for the next generation of space exploration professionals. I know it's a lot of work, and it's a joy to work with you all every year. Thank you. And I have a special recognition, and I don't, it's kind of hard to see, but there's this really pretty lucite plaque that we are presenting to Heather Rarick, who is the chair of the steering committee. She has been our chair for 3 years, and she's rotating off. And it really is just to say thank you for your service and the dedication that you bring to the RASC-AL competition. So Heather will be giving this to you over in there at Johnson, where you live. Johnson Space Center down in Texas. And it's my pleasure to introduce or make the announcement that Dallas Beanhoff will be the new chair for RASC-AL going forward. So that's it for my thank yous. And I'd like to turn it over now to Janice Miller, who has some really fun special prizes. Thanks, Jan.
Thank you, Shelley, and thanks to everyone for helping make this forum an amazing one. While we could not be here together, we were able to participate together apart. And we wanted to give a special shout out and some prizes to those who decided to join us. You were able to see on the LinkedIn that we have our NASA notebooks and our NASA stickers. We have our NASA mugs, SpaceWorks cups, and some t-shirts. We do have special sizing for t-shirts, so we will be in touch with our winners to see if we can get them a t-shirt in their size. We are going to change our format slightly to accommodate a few unexpected categories of prizes. I had the joy of interacting with each of you on LinkedIn, and I saw some things that I wanted to give some prizes for. So we will just do a drawing for one prize among our bingo players. We will also do prizes for mocktail participants and meme participants, and then a special prize for virtual engagement. So, and just a reminder that happy hour was our cutoff, so we are considering just participants who posted prior to that. So our first prize goes to Alondra Rodriguez Fuentes from UPRM. She is a team member, and that is for the mocktail recipe submitted for the touchdown on Cirrus in honor of the Decipher project. And I will say I will try this one. It looks delicious. And it's very space-like. So thank you for submitting that. We will be mailing you your prizes. I also will have a prize for Devin Lewis of Rutgers University. That was for the bingo prize. We entered everyone who participated. Thank you for submitting your bingo cards. And we did a drawing for one winner among those players. And I enjoyed your Baby Yoda memes. So thank you for submitting those. And I'm excited about how excited you are about the launches. You also got 4 across the top. Most people got 4 across the bottom. So thank you. Another prize will go to Sanskar Agrawal for submitting 2 memes, both of which made me laugh and made our team laugh. So thank you for submitting those. We had to give a prize for people who made us laugh. So we kind of changed things up a little bit for that. And our special prize goes to our most enthusiastic online contributor from the start. And that goes to Joseph Cunningham. And you were literally the first to post on LinkedIn. You were the first to ask a question in our orientation. And I believe you're also the first to ask a question in our orientation or in our happy hour here tonight. So we wanted to give you a special prize package. From there, I'm going to turn this over to Chris Jones, one of our judges, and he will start the RASC-AL show.
Hello, everyone. And first, I want to just take a moment here and say thank you all for all of the participation you've had here. I think Janice highlighted some of the winners there, but honestly, A lot of you have made tremendous contributions here. I know in my role here as a sponsor, in my role as a judge, it's been really exciting to see all of the ideas that have come here and think about how we can use those going forward. However, deciding who had the best idea, recognizing who wrote the best paper, identifying all of those bests ofs, those come just a little bit later. For those of you who've been here before, you know what I'm here for. For those of you who haven't, before we get into the more serious awards, we like to give what we call the RASC-ALs. Fun little things that jumped out to the steering committee and the program staff over the past few days that just struck us as interesting or funny or just really novel. And so to that end, I'm going to take you through the RASC-ALs we came up with. If we were doing this down in Cocoa Beach, I'd actually have a prize to hand to each of the winners. Instead, I've got a little prize here I'll show on camera, and it will stay with me, never to go to you. So sorry. In any case, one of the things that I think we always like to look for here is part of the design you do in your concepts. And one of the things that I think is a key to any design is to have a good logo. Now, there's a lot of different ways to judge what makes a good logo and what makes a poor logo. In this case, what makes a good logo is what jumped out at me and the rest of the steering committee. And earlier today, when we had our presentation from the University of Maryland's Mallard team, the sight of a flying duck taking off from Mars with a little helmet on its head was the clear and obvious winner. So our best logo award goes to the University of Maryland Mallard team. And as a prize, I'll show you one of my favorite logos. It's the meatball, the second best logo NASA has ever done. Worm forever. Now, part of what it takes to put together your concept is to give a good illustration of what you're trying to do. And in some cases, part of that is left to the imagination of the teams to really fill in. Or rather the imagination of the judges to fill in what the team has proposed and presented. And in the case of our next award here, it was pretty quick that we figured out that looking at just how the University of Illinois was proposing to get around on the moon obviously reminded us of the moonwalk made famous by Michael Jackson. So to that end, for the best moonwalk provided by any of the RASC-AL teams, we have a lovely sparkly glove handcrafted by our very own Tori O'Leary here to recognize your outstanding tribute to Michael Jackson in the design of your concept. Of course, as we say, one of the purposes of RASC-AL is to be able to take the ideas you give us and let them inspire us at NASA to turn them into reality. Sometimes that goes really well. One of the very first ideas to come out of RASC-AL is a drill that is now operating on Mars. Sometimes we get a little bit more creative in our interpretation. And this next award here, which goes to the Virginia Tech Delphi team, recognizes their discussion of how they would use a portable radiation shield to protect their crew from radiation during deep space travel. In their case, they had a large barrier of polyethylene that they hauled around like some Middle Ages shield. In our case, I have that most simple and straightforward of portable pieces of radiation protection, UV-resistant sunglasses. So, Virginia Tech Delphi, congratulations on developing a wonderful idea for protecting radiation that is probably more useful than me wearing this on a space mission. Of course, in order to talk about your missions, one of the things we ask you for is to talk about the risks associated with your missions. And in doing that, we always like to look and see, well, what risks do teams really prioritize? What do they think are those long poles, those things that they've got to deal with in order to make this work? And I think the risk that really resonated with us, actually, there were several risks that resonated with us from this one team. But the one I'm taking the moment here to recognize comes from the United States Naval Academy, where they recognize that one of the greatest risks of a round-trip mission to Venus and back again was the health of their dear mice. those dear mice who are going along to help us understand physiological effects of deep space travel, and along the way will hopefully return to us. But because of that strong recognition there, we would like to provide the PETA Award to the U.S. Naval Academy, and with that, several additional rodents that could journey along to make up for any that you lose along the way. So, good luck with that, Navy. Now, that's some discussion and some thought about how your concepts work. But a big part of RASC-AL is how you tell us the story of how your concepts work. How do you convey what it is you're doing? And one of the things we always like to look for, it's one of the things we grade you on in the matrix, is just how effective are the visuals and such that you produce in order to illustrate your concept. Maybe even more so, and certainly near and dear to my heart, is how well you, the people who are presenting, manage to convey yourselves. And I think for us, the video and graphic production associated with what the University of Puerto Rico Mayahuez did, being able to green screen in all of their team members onto their slides, really inspired us to give them either, depending on how you feel, the Industrial Light and Magic Award for Outstanding Special Effects, or simply the Local Weather Forecast Award, depending on how you feel about your special effects. For us, as the prize for that, we'd like to throw it back to one of the all-time great inventions for special effects, 3D glasses. We didn't wear these during your presentation, so if we missed out on something, please let us know, and I'm sure all of our judges will take the time to go back and rewatch your presentation wearing these. I'm getting a headache wearing them for 20 seconds, so it will be fun. That's the visual side. There's also the audio side. Now, for the presentation, to me, the audio side means how well were you able to record and broadcast what you're doing, and we'll talk a little bit more about that in a minute. But before that, there's also the interesting choice to provide soundtrack to what you're doing. And in this case, the one that really jumped out to us came from Virginia Tech's Project Aurora, when along the way, they provided quite a bit of elevator music. Now, elevator music is great and all, and so we'll give you the award for the best elevator music. But for our money, the prize we want to give is a recommendation of a slight soundtrack upgrade. So we have this lovely album by Elton John that you can play for the crew over and over and over as they go all the way out and back again. All right. That covers the first round of these. Where am I next? Oh, yes, I'm talking about audio. Obviously, you put a ton of effort into what you do. And there's a ton of work it takes to make these presentations that then come to us to watch. And sometimes you have so much on your plate that a couple of little things might slip through the cracks. In this case, what really caught us in, I believe it was the very last presentation of today, was as the University of Southern California and Chicago were rolling along, we finished an excellent description of their propulsion system with a nice, simple, cool, from, I don't remember the person's name who was producing it, but it's exactly what I would say as soon as I was done recording. I just hope I would have remembered to press stop before that made it into the final cut. So, as a reminder to you for future things and hot mics, we have produced this lovely on-air sign that we can recommend you have handy to know when you are and when you aren't on the radio. I'll leave it on to remind myself that I'm still talking to you. All right, that's the visual side, that's the audio side. Let's talk about the physical side. Let's talk about the structure of what you do. We actually have a number of RASC-AL challenges. Some of you may be familiar with RoboOps of the past, the current special edition, the Moon to Mars Ice and Prospecting Challenge, any number of other competitions that our wonderful program staff here puts together. And in many of those challenges, but typically not RASC-AL, one of the things we look for is a hardware demonstration. RASC-AL, we usually don't look for that, so it was a pleasant surprise to see the excellent testing work that the University of Arizona did for their concept to get down into the lunar lava tubes. To recognize your demonstration of, by far, the best practical demonstration of a RASC-AL concept, I have procured some lovely knockoff Legos, in what is probably a knockoff red from the official Arizona red. My apologies, but there's only so much I can do at the Dollar Tree in Hampton, Virginia. In looking at your concepts, you have to decide where to put your focus and where to take advantage of the expertise you have available. There's propulsion, there's life support, there's crew systems, there's power, there's cost assessment, there's risk assessment for little mice flying along with you. All of these are important disciplines, but one of the ones that really stood out to us for the thoroughness of the discussion was the work in structures by the University of Maryland's Volant team. Even among a number of excellent descriptions of structures from other teams, you really went above and beyond, and we are awarding you our Structural Engineers of the Month. And with that, a set of magnetized little bolts here that you can use to build Volant, or some very, very, very small piece of the vehicle. So congratulations, Maryland. Now, as you start getting into the details of the structures, they're nuts. Thank you, Ken. They are nuts, and so am I. As you start getting into the details of what you do and the details of what you present, you really like to show your work. You like to show the details. Sometimes you really like to show the details. Sometimes you really, really, really give us every single significant figure you possibly could of the details. And I know that one of our judges, Melvin Farabee, called that out on more than a few occasions. But here we really want to recognize the outstanding contribution of significant figures by the University of Texas at Austin's Revere team. Your significant figures helped get Melvin started in the RASC-AL presentation here. And for that, and especially because you're from Texas, we have here a lovely Texas Instrument calculator that will give you far more digits than you probably need to report in any given section of a RASC-AL paper. Okay, so you can have lots of digits because they're significant figures. You can also have lots of digits because you're talking about a very, very big system. And admittedly, it was the most ambitious of the 5 themes, but that series mission lends itself to some very, very big systems. All 3 of our concepts there were definitely large and massive and required tremendous numbers of launches and integration and pieces to come together. But at the end of the day, when you make the choice to do an all-up round trip to 2 series on a mere 900-second spitter of a nuclear thermal propulsion system, you end up with a launch mass from cislunar space on the order of 1 million kilograms. And so our biggest vehicle award goes to MIT's Cheetah team. And for that, I provided 1 more pound. It is a pound, not a kilogram. 1 more pound to contribute to your mission. Hopefully you have the delta V margin to pay for it. All right, in order to make your concept close, sometimes you have to come up with some new ideas. And in fact, that is one of the things that really jumped out at us for this next award here, which was the ability to come up with a really novel way to think about how to approach executing a Venus flyby mission. See, we here at NASA are so used to the idea of we have to design and build our own systems that it would never occur to us to just call the local Starship dealer and lease a couple of vehicles to go do a Venus mission. But for Northeastern University, that's exactly what they did, and as a result, they were able to dramatically save on the costs required to do their flyby. Now, those of you who have leased a vehicle before know that it's important to keep that in good shape in order to make sure that you're going to, not be charged anything extra. So our Don't Scratch the Paint Award goes to Northeastern University for that leasing plan. And to that end, we have for you some extra paint to cover up the vehicle, just in case you happen to get a couple of scratches on it, say, flying by the hellscape that is Venus. All right, making your concept work requires, oh God, I've got a pun. It requires a lot of steps. Indeed, it really requires finding a way to elevate and dominate, to really get not just your idea, but your astronauts off the ground, in order to be able to rise to the occasion. And as we looked at all of the concepts for the Mars Ascent Vehicle, there was one that really climbed to the greatest heights to talk about how the crew would actually get back into the math. So, our Stepping Up Award for the best attempt to describe how we would get the astronauts into their minimal MAV goes to the Virginia Tech MAV-1 team. And since they may still have a few details to finish off in closing this, we, here at RASC-AL, are happy to provide, but not really, your very own step ladder to haul out there and use for the astronauts to clamber from the Martian surface on up into the MAV. If you would rather stick with your tunnel concept, I can understand. After all, I'm just sitting here posing with this thing for as long as I need to make this joke land.
They don't have the mass budget for it.
Of course, it's one thing to have a vehicle that's going to take off. You land it, you go do your mission, you take off, and you go again. Or you land it and you hang out in a habitat, and then you're ready to go. But what it really gets down to is that ability. Ooh, I have to see what happened to my RASC-A. I think it might be, did you have sent to me the, yes, that, no, that, because that turns into that. Yes, haha. We're so efficient here, we actually recycle our RASC-As. I think the thing that really stood out to us to inspire this next one here is that not only did the University of Maryland Helps team come up with a mobile concept for a RASC-A, for their system, but it inspired us to come up with the RASC-A to talk about their travel around the lunar surface in style. So the Space Glamping Award goes to the University of Maryland, and for that, we would like to remind you never to quit your daydream with this little tiny sticker that's going to zoom in here, and that Tori is frowning at me for having gone and used for a RASC-A rather than some higher purpose. Tori thinks it's adorable. I'm actually not in trouble. Oh, good. I can finish telling all my jokes here. What do I have left for you? Oh, yes. I have, this may have actually been the one that just about had us laughing the most. You have to take the right steps to keep the astronaut crew safe in order to do their mission. And in the case of what the University of Texas team that produced Camper was doing, one of the things they recognized was that in order to clean the regolith off their solar array sun tracking mechanisms, they had, I will admit, a very straightforward plan. Have a crew clamber up on a ladder and keep it clean. The danger, of course, is on the off chance that you grab the wrong part of the solar array and manage to get yourself electrocuted. And then, as our own, I believe the title was suggested here by our own judge, Ken Bocam, in space, no one can hear you being electrocuted. So, to that end, to keep the crew safe from UT Austin, we have one pair of rubber gloves for you to provide to the crew in what is kind of sort of a Texas burnt orange. Again, apologies for perhaps not exactly matching it, but you work with what you've got when you're on a mission to another planet or a moon. And with that, we come to the last RASC-A I get to give. See, I get to give a RASC-A that then sets up another RASC-A. I get to award the best dressed team. I'm getting to award this. Pat is not getting to award this, which means that some other award for some other function of fashion may still be to come for those who might be wondering if they're getting off clean this year. But to recognize on my simple, humble side who the best dressed team was, at the end of the day, that has to go to the Viduru team for those sharp-looking suits during their presentation. In your honor, I have decided to upgrade from my current outfit of on-air sign and button-down shirt to on-air sign, gone, button-down shirt on, and extremely fancy tie. It maybe doesn't quite match what you guys have going on, but it's the best I can do on short notice. So on that note, I'm done narrating the RASC-As. I still have one visual to show for the RASCs, but Pat, it's over to you to take it away with perhaps the most important RASC.
Thank you, Chris. Chris has done a fantastic job of coming up and becoming our host and sponsor and doing good judging, but he's still not there yet with the status and experience to present the most prestigious of all the RASCs. Maybe someday, Chris, your time will come. This is the most prestigious RASC that we have had ever. This was an award that's RASC-AL's been going on for about 20 years. I think we've had this award probably about 10. I'm not really sure. This award singles out the person who conveys the spirit of RASC-AL's through fashion. And the person who always got this reward for years asked us to stop awarding it to him. And so we've decided to award it to other folks, but we've named it after him. So I have the honor of announcing the Dave Aiken Fashionista Memorial Award. So it goes to the person who, again, exemplifies the sense of fashion that both Dave Aiken and RASC-AL's endure. And so without further ado, this particular gentleman, and it goes to males or females, it doesn't really matter. But this particular person, he crafted and printed out a three-dimensional bow tie. And we have never seen that before. The most innovative fashion experiment ever to happen at RASC-AL's. So I'm proud to present, he knows he's getting it, Max also from Virginia Tech. Congratulations. Oh, he's got copies. I'll expect the whole team to be wearing those.
One for every
Max,
occasion.
can I ask you that you send one of those to Dave Aiken so he can upgrade his game? Chris, do you have a picture of the award? Oh, there it is. Whoops. So Chris is holding it up. It's basically I think it's just a picture, but that's okay. It's more of an honor than anything else. So Max, thank you for exemplifying the fashion that is RASC-AL's. Next year, we hope that more people continue the fashion trend that you have pioneered, because it's all about innovation, pioneering, and taking that next step. And you have done that, sir. Congratulations. I salute you. All right. So this is where we end the silly stuff and we get to the more serious stuff. We had something new this time that we really found touching, and it really deserves an acknowledgement. Now, during this particular item, I was in one of my other 10 parallel meetings going on, but Melvin Farabee was there, and he thought it was really worthwhile of acknowledgement. So I'm going to switch over to Melvin and let him get this award.
All right. Good evening, everyone. And we as judges, we're sitting here and we're listening to 16 presentations over the course of 3 days and evaluating and all. And we listen to the presentations via video. So it is it's pretty cool, frankly, to do it in this virtual format. However, there was just one particular video that, one other thing. Even though, as you notice in the WebEx chat, you didn't see any judge interaction. And that's because we had our own chat on a different collaboration tool. So we listened to this particular video. In the first 3 some odd minutes, it was like, wow, given the environment of the last year, given all of the things that have happened over the last year, given the fact that we are all home and we're still alive, it was these first 3 minutes, all of the judges were going, wow, that was a great intro. Wow. Oh my goodness. So we just, and I want to single out the person who is, I think it was Jonathan Rodriguez on the Viduru team. Man, it was amazing. It was amazing to dedicate your design to Mae Jemison, and the way you dedicated that design. It was truly worthy of it was truly outstanding work, and we just wanted to let you know that you touched the soul of all of us, and it's pretty hard to do considering the group of folks that we have. So congratulations, keep up the good work. Thank you.
Thank you, Melvin. Okay, now we're going to move on to our these are awards. These are real things. These are things to put on your resume. We're not to winners in theme and overall winners yet, but we're going to talk about the best technical poster, best paper, and the most innovative concept. For best technical paper, and again, this is one that I saw immediately, and I actually sent it to some folks in NASA as soon as I saw it, goes to UT Austin. For their permanent exploration residence, their camper paper. No, that's poster. I'm sorry. Oh, I just screwed that up big time. Technical poster goes to camper because it really just it drew us to it. It's well organized. The graphics are great. It pops. You see it across the room, and everyone thought that this really represents the way you get people engaged into a study and a concept. So, congratulations to UT Austin. Very, very good. So, bravo. Well, I already spoiled it because this next award goes to UT Austin, but this is for Revere. So that's the paper I sent out immediately afterwards. So UT Austin, Revere, congratulations, best technical paper. I'll try not to mess that up again coming next time. All right, so we have one more. This is most innovative concept, and it was really interesting. Several of the judges and myself, who's not a judge included, when we saw this, we went, you know, I never thought about that. And there's very few of these RASC-AL things that we haven't thought about in one way or another, but this is the first time we saw this. And this was for Virginia Tech Project Aurora for their space elevator. They also had artificial gravity and biological structures. So they had a lot of innovation, and RASC-AL is about innovation. So most innovative concept going to Project Aurora, Virginia Tech. So congratulations there. All right. Oh, Excellence in Innovation Award. Okay, that's what it's called. Very cool. Oh, look at the Hokie bird there. I'm a Hokie, by the way, so congratulations, Hokies. Let's go on now to the winner in each theme. We're going to start off in sort of chronological order as we went through the themes. So our first theme back on Tuesday was Distributed Lunar Sample Aggregation Analysis and Return to ISS. The winner is University of Texas Austin for Revere, Regolith Volatile Extraction and Return Expedition. Congratulations. Really awesome paper, awesome concept, incredible presentation, and great response under fire from the judges, thoroughly professional. So we were very, very much impressed with that. And that's, I know a lot of people back within NASA who want to get more samples back from the moon, and they want to actually have alternate uses for ISS. So it scratched the itch. So very good. Congratulations. All right. Our next category was the Durable Low Mass Lunar Surface Habitat. And these folks are no strangers to winning things. In fact, Ryan Joyce, he got an award for habitat design at RASC-AL before, and continues the University of Maryland tradition with the Habitat for Exploration in the Lunar Surface Helps. So congratulations, Maryland, for once again scoring a first place in a category. Very good concept. Next, Ceres. Ceres was one of those topics that, you know, we like to keep RASC-AL on the edge. Yes, we anchor it in our current architectures, but we like to stretch out a little bit into the future. We hadn't really done a mission to something between, Mars and the outer planets. And of course, there's a lot of people who like the expanse, and we start thinking about Ceres, and it could be a logical next step beyond Mars. And the question always arose: well, which is easier, Mars or Ceres? So we've actually sort of had both topics in RASC-ALs, and we found a lot of innovation going on in Ceres this time. So we were very excited to see those concepts. As again, we noted that Virginia Tech was super innovative with Project Aurora. However, sometimes innovation is just not quite enough. And the winner of the series category is University of Puerto Rico Mayagüez, Discover Endeavor, Series Interplanetary Pathway for Human Exploration and Research, Decipher. So once again, Puerto Rico is scoring big here. Very, very good detail, content, presentation. All of it was just superb. Congratulations. Now, let's move on to the next category. Which is harder, Ceres or Venus? Well, of course, if we were to actually have crew land on Venus and survive there, that would be a little bit harder than Ceres. But Venus is an interesting step on the way to Mars, and a lot of our participants told us how that was and everything. It was a close race, but I'm proud to announce that the U.S. Naval Academy Venus Interplanetary Research and Testbed for Uncharted Exploration Virtue won first place in the Venus Flyby Mission category. So congratulations. You guys got one over the Space Force. Maybe someday the Space Force will show up here. I don't know, but you guys did it and did a great job. So congratulations. We really liked your concept. That leads us to the last category, which is the Minimum Mars Ascent Vehicle. Again, lots of good design, lots of detailed work in there. It's a hard problem. Doug Trent was telling us in the interview thing how hard it was and all the challenges. It's a tough nut to crack, and this is why we wanted to look towards you guys for a little bit of innovation and outside the box thinking. We always are working hard on it. It's the toughest part is getting down. The next toughest part is getting up from the surface of Mars. So thanks for all the good hard work. But once again, first place, Minimum Mars Ascent Vehicle, University of Maryland for Mallard, Mars Lightweight Low Cost Ascent Rocket Design. Way to go, Maryland. So Maryland now has two first place categories. So they're a force to be reckoned with, as always. So congratulations, Maryland. Okay, we get to the next part. This is overall first and second place winners. So each of these two teams will be awarded a stipend to present condensed versions of their presentations at the AIAA Ascend Conference. That's in November. So this is it. This is the best of the best. So, of course, they probably won something already, but they're going to win something again. This was our longest discussion of the day. We went back and forth, pros and cons. When you have two really good presentations, reports, concepts, ideas, it's very hard to pick a winner. So we considered all the factors. We can consider the score. And second place went to University of Texas, Austin for Revere. So UT, fantastic. Second best of the best. Where do they get these videos from? Fantastic. All right. Without further ado, let's talk about where we ended up with first place for RASC-ALs 2021. We'll call it a threefer. University of Puerto Rico, Mayagüez for Decipher. Congratulations again. Incredibly detailed, thorough, thought-provoking. You guys are a force. So congratulations, kudos, tribute to your mentor, everything. You guys just touched on it all. It sounds like a broken record, but everyone needs to look at what they've done, what they do. And by the way, they're a club team. this is a club team doing this. Maybe they have the edge now because we're all virtual. I don't know, but it just fantastic. Very proud of you guys, and I look forward to seeing the advisors and maybe some of the students next year in person in Cocoa Beach for the 21st anniversary RASC-ALS competition. No more web streaming, no masks, pool deck. We'll get back to it. And at the very end of this, Tori, I have one question I'm going to ask folks. But, oh, look, there they are. Look there. There's our winners right there. Let's all give them a sitting ovation here. Very good. You guys are awesome. Got any sound there in Puerto Rico? Fantastic, guys. All right, Tori, I'm going to hand it over to you.
Hi, Pat. Before we send it over to Tori. Oh, there we go. We got your video. Congratulations, Puerto Rico. Good job. That's great. A three-peat. That's incredible. Way to go. All right, just before we bring it to Tori to bring us home, two quick things. Important. One is that Mel forgot to mention that to the Viduru team that he has a connection with Mae Jameson, and he is intending to forward your inspirational video directly to her so that she can see that and see the shout out and the appreciation and the dedication that you provided to her and the inspiration on that video. So I wanted to let you know that she'll be receiving that. And my last little thing, it's important, but I think we should all give Tori O'Leary, our fantastic MC, another sitting ovation for her hard work. Really doing such a great job as our Master of Ceremonies and keeping everybody on track and doing such a wonderful job. Tori, you're amazing. She's sitting right next to me, so watch this. Tori, we love you. Yeah, Tori. All right, way to go, Tori. Thank you so much. I'll give it to you now.
All right, I'm back. Hopefully I'm not reverbing in your speakers now. Thank you everybody for joining us. I want to say congratulations again to our top two overall winners, Puerto Rico and UT Austin, and congratulations again to everyone. You all are finalists. You guys beat out a lot of really competitive and really incredible proposals earlier this year, and the work that you guys have presented is just absolutely incredible. So we want you to feel proud of the stuff that you've presented this week, and we want you to move forward in your academic and professional careers knowing that you guys have the stuff. And I want to give so much thanks to Pat. Pat has been behind the scenes for all of your RASC-AL presentations, even if you haven't seen him. And he has had only amazing things to say about the incredible quality of your presentations. So we just want to say thank you, Pat, and you're just our amazing champion. So this concludes the RASC-AL 2021 awards ceremony. I want to wrap us up with just a couple of things. There is a NASA feature story which is scheduled to be released tomorrow, so we invite you to visit the RASC-AL homepage tomorrow afternoon and read and share the story. We are still expecting it to go out, but it's possible that we have a brand new federal holiday, so there's a possibility it might not get posted until Monday. If it doesn't get posted until then, it'll be there then as soon as it's up. We're also going to be sending out a survey. It is 5 minutes long, super duper short, and we want you to know you can actually access that survey by grabbing your phone now and using it to do the QR code here. I know we've used that on a lot of menus over the past year instead of having physical ones. Well, you can use it now to visit our 5-minute super short RASC-AL survey, and we just want to hear about your experiences over the past week and get your feedback. In conjunction with that, we've received and shared out all of the resumes for those of you who submitted them with your registrations, but we'd love to hear from you on the LinkedIn page. If you guys have any job opportunities come up, we want to hear about it. We want to hear you guys getting positions, you guys moving into the industry. We're really excited for you and your futures. Our activity on the LinkedIn will be reduced after the forum, but we do encourage you to keep engaging, sharing, and collaborating with each other, possibly on next year's RASC-AL themes, which should come out later this summer, so keep an eye out for those. And finally, there is one person who does not get thanked during the welcome, and I want to give Shelly all of the thank yous. She just dragged me into her screen earlier. I'm not going to do that. But of
Here
course,
I am.
Shelly works tirelessly behind the scenes to make sure that RASC-AL happens every year to the amazing quality that you guys see it. And we just want to give her an extra special shout out. So thank you, Shelly.
Thank you.
And Pat, I'm going to give the floor right back over to Pat for just a second.
All right, so there's lots of questions in the chat about the themes. So I have a question to you guys about the themes. This year we had some very broad mission concept studies that looked at large architectures. We'll continue to do that at RASC-AL, but I'm looking for a show of thumbs up or thumbs down from everyone online if you would like to see one or two more focused systems concepts, like a widget that operates on the surface instead of the whole architecture around it. And this may include actually building a prototype or something. So I got nothing but thumbs. Got 2 thumbs down. Okay. Look at them coming. A couple down, but it's the same thumbs down from the same guy. I can see that. All right, I'm getting a good sense here, one way or the other. So thanks for that, because these guys get on me very quickly about topics, and the topics that we have to choose, we want them to be relevant to our current mission and our future missions. We want them to engage you guys and get you to understand what our missions are, so you're ready to hire when you get out of college. And we want that innovation. So they have to meet all those criteria, but if they're maybe a little more focused, I'm seeing that might not be a bad thing. So thanks for the feedback, and hope to see some of you next year. Bye-bye.
Thank you, Pat. And actually, the survey asks what you would like to see out of future RASC-ALs. There's a question down at the bottom that says, what are you looking for in future RASC-AL themes? We invite you to, use that QR code, or we're going to send a link out tomorrow or next week. Go ahead and just click the link and pop in your answer. We want to hear from you. What do you want to do for a RASC-AL theme? Other than that, this concludes the 2021 RASC-AL Forum. We want to thank you guys all again for joining us and giving us the incredible opportunity to join you this week in your homes and offices. And we look forward to seeing you guys next year. Thank you.